Hello everyone, today I'm going to be doing chapter 5, problem number 52. This problem states that a child is twirling a 0.012 kilogram plastic ball on a string in a horizontal circle whose radius is 0.1 meters. The ball travels once around the circle in 0.5 seconds. So before I even begin looking at part A and part B, I'm just going to draw a picture of this and get a visual on it, and also label what we have. So we know that there's a string that a ball is on, and it's being twirled in a circle. This radius is a little bit long, it should be about half that circle. All right, so we know that radius r is 0.1 meters. Now, this second component is the amount of time it takes for this ball to go around the circle, which is a period. So that is 0.5 seconds. And we also know that the mass of this ball, so m, is 0.0120 kilograms. All right, so now that we know what we have and what the situation is, let's read part A. Part A says, determine the centripetal force acting on the ball. All right, well, if we go back, the first thing that I like to do is just kind of write out the equation so I have an idea of where I want to go. So centripetal force equals mv squared over r. And if I'm looking at this problem, I see that I have an r, I have a mass, but I don't have a velocity. So how can I figure out velocity? Well, I also have this component of period, and a period is just the distance of the circle over the velocity. So, in other words, it's the circumference, 2 pi r, over velocity. And this is how I'm going to get my velocity for this force. So let's rearrange this equation really quick. Now we have something equal to velocity. So I'm going to go back and plug velocity into this equation. Now we have to be careful because it is squared. So let's do the squaring first before we mess anything up. So 2 squared is 4, pi squared, r squared, divided by t squared, and then finally times r. Looking at this equation, we can already see that this radius is going to cancel with one of our radius. So the centripetal force is going to be equal times mass times 4 pi squared divided by period squared. Do we have all those variables? Yes, we do. So we can just plug them in. We know our mass is 0.012 kilograms. 4 pi squared is just a variable on your calculator. And we have period squared. That is a terrible S. All right, so if you plug that in the calculator, make sure to pay attention to the squares. You should get that centripetal force is equal to 1.189 newtons. All right, now let's go back up to part B. It says, if the speed is doubled, does the centripetal force double? If not, by what factor does the centripetal force increase? Well, we don't have to answer this question using the variables that we've looked at. We can just generically write out the equation and see what would happen if we double the speed. So again, let's just write the equation for centripetal force. All right, so if I double the velocity, that would be 2v over r. And there is a square here, so if I square that out, it's going to be 4v squared over r. So does this double? It would double if we didn't have that square. but because 2 squared is 4, it doesn't actually double, so the answer is no, it actually quadruples. So that is the problem, and I hope you learned a lot. Thank you for watching.